we are going to do these two challenges for our experiment. So for the first one, create a Python code to blink an LED using Raspberry Pi. And the other one is using the concept of blinking LED and a push button. Create a circuit that illuminates one of 8 LEDs in sequence every time the push button is pressed. So this is the requirements they need. You must use 8 LEDs and they must be lined up. Every time the push button is pressed, the currently lit LED goes dark and the next one illuminates. There must be only one LED lit up at any given time. So it means that there are 8 LEDs that it's being lined up, and every time the push button is pressed, the next one should be lit up and the previously one should be turned off, and only one LED will be lit up at any given point of time. So the tip given is to use Raspberry Pi 4 as the microcontroller of our Raspberry Pi. As we can see, we use a virtual monitor for this with using a VNC viewer. So with this software, we can access the desktop environment of our Raspberry Pi. So to create the code, we will click here with the Raspberry Pi icon, then go to programming, and then we will choose the Tony Python IDE to type our program for the Raspberry Pi. So as we can see, this is the code for the challenge 1. So we declare two modules which is the GPIO0 and time. So we can see that from GPIO0 import asterisk. It means that everything inside the GPIO0 should be imported in this program. The same goes with the time. So everything, the modules inside the time is imported, since we do not declare a specific type of module for the program, so we use asterisk. I think this is the safest, since we don't know if something is needed to be declared. So with using asterisk, everything inside of the GPIO0 and time will be imported for this program. So next, in line 4, we assign a variable for the pin out of 23 in the Raspberry Pi 4, and we name it as LED. So the LED is equals to LED and the pin out number, which is 23. So this means that on that pin there is an LED, that is the LED pin. So we created a while loop. It means that this line under this while loop will run indefinitely. So we can see LED.on to turn on the LED, and then sleep 0.5 to have a delay of a half of a second, and LED off to turn off the LED, and sleep at zero point 0.5 to have the delay of half of a second. And since it is under the while loop, it will run indefinitely. So this is this is the uploaded code for the blinking LED. So we can see the LED blinks in on a half of a second as we declared on the code, and it is connected to the pin 20 on the GPIO 23 of the Raspberry Pi and to the ground of the Raspberry Pi. As we can see, the only cord connected to the Raspberry Pi is the power source only. So we can say that we can program Raspberry Pi remotely, since earlier we used a virtual desktop for our Raspberry Pi. This is the code for the challenge 2, which is looking back for the requirements. There must be 8 LEDs. Every time the push button is pressed, the currently lit LED goes dark and the next one illuminates. There must be only one LED lit up at any given time. So we will back to our monitor or the desktop of the Raspberry Pi. This is the code for it. So first, we will import library modules from GPIO 0 with using the asterisk. So everything inside the GPIO 0 will be imported in this code to enable to avoid some errors in running the program. So we declare a variable count, which equal to 0. This variable will be used in counting the number of button presses able to lit up the next LED. So next is the variable button, which is equal to button and the pin number. This is a new function. It means that we declare that GPIO2 is used for a button. This is also included from the GPIO 0. That is why we use asterisk to avoid longer line or to save time in typing or declaring functions that we are going to use. Since Python, if we are going to use a library or a module, we should always declare it by taking import. So for example, if we are going to import math, or we import math, so we use from math import then asterisk. So everything that functions under the math library will be can be used in the program. That is it also the same concept from this GPIO 0 also. So next is declaring the 8 LEDs from 1 to 8, and this is LED and then declaring the GPIO number. This means that those GPIO pins are connected to an LED. So the next portion of the code is where we can light up one LED at a time by pressing a button. So it is under the while loop to run the code indefinitely. So first, we have button that wait for press. This means that the button will wait for pressing it, for the user to press the button. So next part of the code is button dot wait for release. It means that when the button is released, it will consider the button is being pressed. So this is the counter, which is count equals to count plus 1. So it means that the value of the count will increment by 1. This means that these two functions, which is wait for release and wait for press, is to determine that the button is being pressed. If it is pressed again, it will add to the current number of the count. So proceeding to the if-else statements. So first, if count is equal to 1, LED 8 will be off, which is the last LED to be lit up according to the requirements, and the LED 1 will be on. So it means that the LED 1 will be on if the count is equal to 1. Next is else if count is equals to 2, the previous one, which is LED 1, will be off and the LED 2 will be on. The same goes with LED 3 with count equal to 3, which is LED 3 will be on and count is equals to 4, LED will be on, LED 4 will be on. As we can see that LED 3 will be off on count 4 and LED 3 will be on and LED 2 will be off if the count is equal to 3. The same thing goes with LED to count equals to 5, where the LED 4 is turned off and LED 5 is turned on. When the count is equal to 6, the LED 6 will be turned on, LED 7 will be turned on if the count is equals to 7, and lastly, when the count is equal to 8, the LED 8 will be on. And as we can see, there is a count equal to 0. So it means that it will restart if we press the button again and the count will become equal to 1, so that the first LED will be lit up if we reach the count equal to 8 and if we press it again. So it means that instead of getting the value of count equal to 9, it will reset and will go back to 1. So since it is under the while loop, it will run indefinitely. So this is the demonstration for the LED for LED light sequence by controlled by a push button. So as you can see, the first LED is already lit up since one of the requirements is that the LED will be at least one LED will be lit up. So if we press a button, if we press the push button, so it will move to another LED. So if we press it again to the third LED, to the fourth LED, push it again to the fifth LED, sixth LED, seventh LED, and finally the last LED. So as we can see, we reach the 8th LED. So based on the code, it will reset it and go back to 1. So if we press it again, it will start all over again to the first LED. So since it is under the while loop, it will run indefinitely.